So how does density determine if something sinks or floats? Well, density tells you how tightly compact something is, how close together the molecules and atoms are. A common unit for density is grams per milliliter or grams per centimeters cubed. The density of water is 1 gram per milliliter. If something is more dense than the surrounding fluid, it sinks. If something is less dense than the surrounding fluid, it floats. So let's look at some things in water, which has a density of 1. We know something about an object's density based on whether it sinks or floats. If it sinks, its density is greater. If it floats, it's less. So when it sinks in water, we know that it has a density of greater than 1. If it happens to float, then we know its density is less than 1. And this is very useful for determining relative densities. So anything in any fluid, whether it sinks or floats, we know its density. Something like a metal like aluminum, a small piece here, will sink, but however, not all metals have to sink. If we shape it right, its overall density will be less. Its buoyant force is greater than its weight, and it floats, a lot like a boat. So based on the density, decide if these objects will sink or float in water. Right, sink or float in the space provided after each of these numbers. The density of an object will also tell you what percentage of it will be submerged in water. So if something has a density of 0.9, we know that in water with a density of 1, 90% of it will be submerged. Has a density of 0.5, 50% of it will be submerged. 0.85, 85% of it will be submerged. So we can tell how much of something will be submerged based on its density in grams per milliliter. Now, how do we find the density of regularly and irregularly shaped objects? Now, the first thing we need to do is find the mass, and then the second thing, the volume, and then we divide the mass by the volume and calculate the density. So how we're going to find mass is using a scalar balance. We generally use a triple beam balance. Volume is a little more complicated than just using a balance. There are several different ways we can find volume. The first is if we have a regularly shaped object, like a cylinder, or a cube, or a sphere. There are ways we can calculate the volume of regularly shaped objects, such as finding the length, the width, and the height of an object and multiplying them together. But there's also objects that are irregularly shaped, meaning it's difficult to do that with a ruler and to find the volume. So we have to have some other method. That method is the liquid displacement method. And with this method, we fill up the graduated cylinder, we note where it starts at, we put the object in the graduated cylinder, and it will displace the water and make it go up a certain amount. In this case, it goes from 7 to 9, so we know that the object's volume is 2. And in this case, I would assume it's probably 2 milliliters. So this is how we find the volume of irregularly shaped objects. And after we find the mass and the volume, we can then calculate density. Try some problems. Now, what is buoyant force? How does it determine if something sinks or floats? Well, the upward force exerted by a fluid is the buoyant force. The buoyant force goes in the opposite direction of gravity. The buoyant force is what makes you feel lighter when you go into water. And it makes you be able to lift things easier in water because of that buoyant force pushing up. If something is submerged, the buoyant force actually works more in the upward direction. So there's pressure on all sides, but there's more pressure from the bottom. And that creates a buoyant force going against that force of gravity. And so we can look at these two opposing forces and determine if they're balanced or unbalanced. If they're unbalanced, it's either going to sink if gravity is greater, or it's going to float, the buoyant force is greater. And this is where we come to Archimedes Principle. And this is a way to determine how much buoyant force there's going to be. This is essential for determining if a boat, for instance, if you're designing it, will have enough buoyant force to be able to float. So when we submerge something in water, we put it in the water, that amount that it displaces, that amount of fluid is equal to the force pushing up on it. So if we want something to have a great buoyant force and to be able to float, we want it to displace more water. This is how the hull of a ship works. So the more it's able to displace that water, the greater that buoyant force is that's going to push up on it. And when it has that greater force pushing up, this makes also an overall density less than 1. Notice that the object itself is still made of the same stuff. The same density is still there of the material, but if we look at the overall shape, it displaces water, making the overall volume greater. And since the volume is greater, it has a greater buoyant force. Density becomes less. And when we look at this, it enables us to understand how something like a aircraft carrier can actually float. How can something made of metal this big be able to float? Same thing with huge cruise ships. Well, if you notice the profile, it has a great displacement of water. A whole lot of water is displaced. Well, that's a lot of buoyant force pushing up. And they're designed such that they displace enough to be able to have enough buoyant force pushing up to counteract the weight pushing down. And that's how Archimedes' principle helps us do things like build aircraft carriers and huge cruise ships.